Welcome back to the channel, hope everybody's doing well, and in today's video we are taking a look at this P4E thermocouple potentiometer from Cropico. We looked at another thermocouple potentiometer from Cropico, the P6, and that was aimed very much at the bottom end of the market, a much cheaper instrument. This is their more upmarket version of a thermocouple potentiometer. This one can only read millivolts. It doesn't have the ability to convert that to the thermocouple measurement, so you need your thermocouple tables when working with this instrument. As you can see, it's already in bits because this didn't work when it came to me. We have taken off the front plate so we can have a look at that before we put it all back together. So that's our front plate. The more upmarket instruments did have a serial number, so this one is number 22966. Date is a little bit more awkward to try and establish. In terms of my favourite of going for the actual reference cell inside, you can see here hopefully, this is the reference cell down here, slightly different type. This is a D550A, and you can't get into these ones like I did with the other unit, so I can't date it via that too accurately. We do have a serial number on this, 496895. Scouring around on the internet, there's a D845-F reference cell on EEV blog, which is serial number 461647. That's dated as 1971. That's the closest I can get. There is another one with a serial number closer to this one here, but that's not dated, so I can't use that one unfortunately. So yeah, 1971 is the closest I can get. I would imagine you'd be looking at somewhere around about the mid-1970s, 74, 75, something like that for this instrument. You can see here, this is an earlier version of this instrument, which is worth noting as well. The later instruments had 4mm jacks inside the binding posts here, and they also had a different meter. So you can tell they're slightly later instruments if they have those. But you've got in front of you, these are our 2 millivolt setting dials. One's a potentiometer, one's a selector switch, which is, shouldn't have done that. You can see all the contacts underneath here. You can see the Walkaround resistors that this selects, all individually wound, non-inductively wound. So they're split in half, one going clockwise direction, and then it splits and goes anti-clockwise. We have our on-off switch up here again, same brass copper contacts embedded into the toughened plate here. You can see the detent here, quite clearly visible when you move this around. That's the position, quite chunky. Quite a lot for something that's just millivolts, isn't it really? And then we've got a couple of toggle switches, a spring-loaded toggle switch, selector switch here that you can see. And then we can flip them over. Again, our classic Walkaround resistors on formers there. And for this one we do have a little PCB underneath. That doesn't really help with aiding the date. I did dismantle this a bit more, and there is a little differential amplifier on this PCB here. Part number on that is CA3026, which was manufactured by RCA, Solid State Corporation of America. There is a 1968 catalogue from RCA available on the internet, and that CA3026 does appear in that, so we know that was available in 1968. As I say, I think this actual instrument is a little bit later than that. We have a battery compartment here, 3 D cells it needs. Where's my little battery lid? So it tells you there the 2 of the cells on the red and black, which is these 2 here for the potentiometer battery, and then the injector circuit is just the one on the green and orange here. And as well as those 3D cells, there is a PP3 cell that goes in here as well. This is for the null detector circuitry. And the only other bit is this bit here is a multi-turn potentiometer that's currently in bits, because when this came to me, this is what was all bound up and wouldn't work very well. This is the main control shaft and like a guiding shaft here. This was all rusted and bound up, so I've cleaned this all down, and then we'll be ready to assemble that. And then this one here that will sit on there will then move up and down and is effectively a multi-turn potentiometer. So we need to get that all assembled before we can do some testing for it. But this was all corroded as well, and they've all been cleaned up. But other than that, it was in fairly good condition. So we've managed to dismantle our instrument a little bit more and get our actual Muirhead cell out that's inside here. You can hopefully see now that this is the type D550-A. Serial number on this is 496895. You can see that we have connected up our crop clips onto the top of our standard cell. Now that we've got it out, and if I swing my meter around, you can see we are 1.018675, and we should be 1.01859 on the actual markings of the standard cell. So I would say that's a very good reading indeed. Obviously, to do this, I've set this up to the high impedance mode so that I don't put any load onto this Muirhead cell that it can't handle. So that's that. What we'll do now is try and get it all back together. We're all back together now. Didn't have it stripped out too much anyway, but it's just simple basic hand tools, a pair of pliers, a couple of slotted screwdrivers here. This is ye olde English, so we had a 1/4 socket, an 11 32nd socket, and it was a 3 32nd Allen key for the control knobs, the glove screws in them. But what I did just wanted to show you before we pop it back in its case is our little multi-turn potentiometer here. See, it's started to move. It moves up the shaft now, so now it's all fixed and free. And then back up the other way. So this is the rheostat control for standardising the instrument, and now fully functional. So hopefully we'll be able to get some good readings out of it. We are all back together now. It gets fitted into its wooden box. I believe this is an oak box. Got a carry handle on the front here and our latches to lock it closed, and then a couple of hinges at the back. Some rubberised feet, so this is ones for storage I presume, and then you have the other ones on the other side that you sit it on for actual use, and then our batteries are underneath there. Put this together, and then if we look inside here, inside the lid, you have our instruction sheet there telling you how to utilise it. And then on this one we do have the thermometer. That's what's usually missing on a lot of these that you see for sale. The thermometer is missing, but this one has it, so that's quite nice to see. I'll try and get this propped up so that you can see the front a little bit better, hopefully without the lid slamming on your fingers. And we have here on the faceplate, this is on measurement wise, this is 2 channels for measurement selected from the selector switch here. I'm not sure why it's 2 channels, whether it's for a specific application, whether you set a reference probe up or something like that for comparison to the other channel, don't know. It is unusual. The instruments nowadays do just come with the one measurement channel and 1 source channel as well. I've not seen anything with 2 measurement channels on it. Here you have the actual Nulling meter itself with its own battery supply in here and its own nulling function. And then when you are utilising the controls here, you standardise it using the rheostat here. This is a 2-range instrument, so you have 1 times range and 8 times 5 range. This millivolts dial goes up to 20, and this one goes up to 1 millivolt. So we are 21 millivolts on range 1 and 105 millivolts on range 2. And then down here for our actual measurement we have a operation switch, which on the P6 is just the push button here. This one, it's a toggle switch, so you have a 1/10 sensitivity that direction and full sensitivity the direction. So if you saw the video on the old one, you can see the meter wangs round quite a lot with that. With this one, you when you start to make measurements, you can use the 1/10 function, so the needle doesn't get belted around quite so badly, and then when you've got closer you can use the full sensitivity. So things are going to sound a little bit different from here on in because I've had to change my microphone, as my wireless microphone is interfering with the operation of this instrument, which we will demonstrate to you now. So the first thing to do when setting up this instrument is to set up the null of the meter here. To do that, you switch it to 0-1 position, and you then have to let it sit around for 3 to 5 minutes and let the instrument stabilize itself. Once the needle is stable, which hopefully you can see there, you then use this knob here to adjust and bring it back down to 0. It is quite touchy. That was a fluke. So you can see we're on 0 now. Once you've got the 0 and you're happy there, you then move it to 0-2, and then you can do the same with 0-2, but it won't do that as easy. A bit too far. Okay, so that's now on 0. Once you're happy, you can then switch over to null, and obviously it should stay on 0 there. If I now take my wireless mic, which you can see is turned off here, and I will zoom in a little bit. Not sure where it focuses. If I turn this on, and you can see what the needle does. If I take the microphone away, you can see the needle will slowly start to move back down a little bit, so it's not overly stable. Move it further away, and it starts to go down a little bit more, but then it starts to go back up again. So not at all stable. If I turn it off, and it returns all the way back down to the 0 mark there, which might need a little bit more adjustment again. So there you have it. That's the problem I had with the microphone. After a good half hour of head scratching, I might well add, we can move on to the next item, which is now to standardise it. So the standardising of the instrument is where the P6 starts off at. The P6 doesn't have this nulling of the meter. But to standardise, we need to switch the instrument on to either of the ranges. So we use range 1 there. We flick our toggle over to standardise, and then we have our 1x or full sensitivity. We use the 1x initially, and you can see it's going right over. So we can now use our rheostat to bring that back. Yep, going too far. So once we have that reasonably close, the other way, we can then move to the full sensitivity, and you can see it moves further over. So now we can zero it for good on the full sensitivity, and then our meter will be good to use. It is very sensitive. It does move around a little bit, so you do have to do things very steadily and a bit at a time, which is the nature of these old instruments. Unfortunately, they are quite time consuming to actually use. Almost there. Okay, so we have that as our 0. What we can now do is measure some millivolts. We select the channel that we want, so we'll move to channel 1. I will use my fine control on my injector circuit, and I'll just hook up this. So that is now hooked up. We can turn our injector circuit on. And we go to 1/4, and you can see we are right over. So we now need to add in some millivolts. So we'll add in 9 millivolts there, and that goes the opposite way, so we need to go back. Still opposite. Still opposite. Okay, but not as much. So that's probably needs to go the other way, but then we need to bring up the microvolts on this one, which was set to very close to 9, I would have thought. Here we go. So we're quite close now. Now we can go to full, and we've gone over. And what have we got there? So that's fairly, let's see how sensitive it is. So that's fairly reasonable there. We are on 4.97 millivolts. So if we turn on our key sight, hopefully we can put him where you can see him there. That's 2 down there. So hopefully they're out of the way. And we can plug this now into our key sight and see what reading we get. 4.99 versus 4.97. I think my screen is slowly but surely going on that, which is a shame because it's a lovely instrument. So yeah, that's pretty accurate, isn't it? Can't complain at that really. I mean, that would be the way to measure a thermocouple. What we'll do now is if we go to the ×5 scale and put him on 5, push him around to 5, and then what we'll do is we'll set this up what we can do now, go right over, so we bring you up, it's gone completely the opposite way. Oof. See how fine this actually gets. So difficult to set up. So that's probably about as close as I'm going to get that. So if I now switch my meter back on, and we can see if that correlates ×5, which we go in there, and there we are 27.65. So we've let him settle down a little bit, and we are now reading 27.67, and we should be 5 times by 5.5 is 27.5, so we are 0.17 millivolts out. Yeah, millivolts. Yeah, 170 microvolts out. That's not bad for a 1970s instrument. Yeah, that's quite impressive. We'll have to think of some other experiments that we can do with this. But that's the basic operation of the instrument there. Still seems to be working fine. Bit touchy, bit awkward to use, but that's the nature of these older instruments. They are quite time consuming to use really, but that's all part and parcel of the fun of them. So that's the Cropico P4 Thermocouple Potentiometer, all back up and running. That'll be it for this video. Thanks very much for watching. Hope you enjoyed it, and I'll see you again in the next one.